Hello everyone, my name is Bharanidharan and I am here along with my teammates Ganesh Kumar V and Kumaran S. We are students of Department of Computer Science and Business Systems at EJSPL Engineering College, Nagapattinam. Today we are really excited to walk you through our project Web Development for Crop Prediction using Machine Learning, built under the valuable guidance of our mentor Mrs. S. Sajati Begum S. Assistant Professor. So without further delay, let's get started. Let me start with the introduction. Traditional farming has always suffered from uncertainty. Farmers often struggle with the crop selection and end up with a poor yield and huge losses. Our project uses machine learning to analyze soil and environmental data and provides the accurate and reliable crop recommendations to the farmers. Now let's look at the core problem we are addressing. Soil has key nutrients, nitrogen, phosphorus and potassium, and if those levels are off, the crop simply won't grow well. Add to that improper pH levels and unpredictable moisture, constantly changing climate conditions, it becomes really difficult to make the right farming decision. And the biggest issue is the most farmers still rely on traditional methods with no data support at all. Our goal is build a smart system that gives farmers the right crop recommendation and backed by real data. Let me now walk you through our project objectives. We aim to develop a machine learning crop prediction system that takes soil inputs like nitrogen, phosphorus, potassium, pH, and moisture. We use the random forest algorithm to predict the crop yield accurately. The system then recommends the most suitable crop based on the given soil and environmental conditions. Overall, our objective is to put smart technology in the hands of farmers, helping them to make a better decision and improve their agriculture productivity. Before building our system, we conduct a thorough literature survey, reviewing 6 recent research papers in this domain. One notable paper from 2026 used a multi-layer framework with high-performance computing to handle sparse climate data. A 2024 focused on sugarcane yield forecasting using ensemble learning. There is also a 2025 green AI model that focus on energy efficient predictions. We are also studied advanced approaches like CONV LSTM combined with vision transformation for spatial temporal predictions and genetic algorithms with machine learning for optimized feature selection. All of this helped us identify existing gaps and confirmed that random forest is the most suitable approaches for our use case. Here is the overall architecture of our system. It follows a clean and structured pipeline starting from data collections, moving into pre-processing, followed by model training, and finally delivering a crop prediction and recommendation output to the user. Every stage is connected and purposeful, and let me explain each one in detail. Data collection and pre-processing. Our system accepts 7 key input parameters: nitrogen, phosphorus, potassium, pH, moisture, temperature, and rainfall. The system also validates each input. For example, pH must be between 0 and 14, and nutrition values must be non-negative, ensuring only clean valid data ensures the pipeline. Once collected, the data goes through pre-processing. We handle missing values, normalization features, and apply scaling techniques. This step is absolutely crucial because clean and well prepared data leads to accurate and clean predictions. Now let's talk about the core machine learning concept behind our project, the random forest algorithm. Random forest works by building multiple decision trees and combining their results to produce a more accurate and reliable prediction, reducing overfitting and significantly. It uses bootstrap sampling and feature randomization for better generalization. Let me now talk about the technologies we used to build this project. On the backend, we have Python with SCI Kitlearn, Pandas, and NumPy for all the machine learning operations. The web application is powered by Flask, and the front-end design is used HTML, CSS, and Bootstrap for a clean and responsive interface. All the data is stored in MySQL, and the entire system runs in WAMP server. In terms of system requirements, the software runs on Windows or Linux with Python and the required libraries installed. On the hardware side, the system needs an Intel Core i3 or above, a minimum of 4 GB RAM, but 8 GB is recommended, and 100 GB of storage space. Now let's talk about what makes our project stand out. First, random forest prediction that captures complex relationship between soil parameters and crop yield. Second, feature important analysis that not only tells farmers what crop to grow but also why, based on which soil factors matter most. And third, a smart recommendation system that combines both crop suggestion and yield prediction in single platform. It is not just a prediction tool, it is a complete decision support system designed for farmers. Here is where we currently stand with the project. We have successfully completed requirements gathering, conduct a thorough literature review, collected and pre-processed our dataset, and fully implemented and tested the random forest model. The core machine learning engine is ready and functional. We are now progressing towards integrating the complete web interface. Our first module is the data collection module. This module is responsible for gathering all essential agricultural data, including soil nutrition and basic environmental parameters. It integrates datasets from agricultural sources, sensors, and historical records. Our second module is the data pre-processing module. This module focuses on cleaning and preparing the raw data, handling missing values, removing inconsistencies, and ensuring uniform formatting throughout the dataset. It applies normalization and scaling techniques to standardize input features, which significantly improves the machine learning model's performance and reduce prediction bias. The third module is the model training module. This is where the random forest algorithm is applied to the processed data, building multiple decision trees that learn the relationship between soil parameters and crop yield. The train module becomes the capable of accurately predicting the suitable crops and expected yield under a wide variety of conditions. The fourth and final module is the prediction and recommendation module. This is the user facing part of our system. The farmer enters the soil data and environmental parameters, and the system instantly delivers the most suitable crop recommendation along with the expected yield. To conclude, our project delivers a complete machine learning powered solution for crop prediction and recommendation by analyzing soil and environmental conditions using the random forest algorithm. We provide farmers with reliable and data backed suggestion that helps them reduce risk and maximize their output. We truly believe that combining technology with agriculture can transform the way of farming works, and this project is meaningful step in that direction. We are also planning several exciting enhancements for the future. First, integrating real-time weather data using API to make prediction even more dynamic and accurate. Second, building a multilingual mobile application so that farmers in rural areas can access the system easily in their own language. We also plan to add features like crop decision prediction, fertilizer recommendation, and IoT based soil monitoring, working towards building a complete smart farming platform. And that brings us to end of our presentation. Thank you so much for watching. We hope this gave you a clear and complete understanding of our project, web development for crop prediction using machine learning. We are open for any questions and feedback. Thank you. Welcome to our project demo video. We use PyCharm for our IDE. So this is the folder where all the implementation and datasets are stored. So this is the datasets. It has some several components. Those are all the key features in a dataset. So district name, season, crop year, area, and production. So these are all the key factors of datasets. So after we run our project, it run into the our local port. This is our index page. In login we have two logins. One is admin and another one is user login. By entering as a admin login, we can train the datasets. So after enter to the admin login, we have two feature for train datasets. First of all, we train the dataset. So by using this feature, whenever we get a latest or a new datasets, we will replace it and we will successfully train into our project. Enter a user login. After enter the username and password, we can enter. If you are a new user, you can register into a new register field. So this is our first key feature, which is a crop yield prediction. In crop yield prediction, first of all we will give state and season, district name, crop name, area and year. I randomly give the options. I give cotton. In area field we must give a parameter of area is we should have to give a hectare value. Okay, this is our result page. This is the prediction page. It has some several components. This is gives total tons of the yield, because we trained for a district, so it will give some gives the result for a district, overall district values. Okay, so this is the cost and income and profit. Also it gives the AI recommendation for a best crop for that particular region the year. Based on it gives a AI recommendation, and also it gives the top profitable crops, alternative crops, fertilizer suggestion also it can give. It gives also a farmer tips for improve the efficiency of their agriculture. So this is a second feature, crop recommendation systems. We can get a proper crop recommendation for that particular soil nutrition. So we will give a randomly give a values. So nitrogen we will give 90, for potassium 50, humidity, rainfall we will give 22. Rainfall must be in a millimeter format. Phosphorus temperature we will give 28. pH value we will give 5. So this is the recommendation for best crop. So by based on that soil nutrition, it give the best crop recommendation. Also it gives the soil nutrition. So this is all about our project. Thank you for so much for watching us.